Hello, everyone. We are going to start our next um, presentation, and this is Organizing Quantitative Data, Section 2.3. So, why do we group data? I mean, what's the purpose of grouping data? And that's to simplify large, complicated data sets. Think about it. If you have tons of numbers, you have to have some way to make sense of them. A common place we see group data is um, achievement tests and ACTs and SATs. A lot of times they'll group it by socioeconomic groups and things like that. Now, this just helps us to organize the data and to help us focus on particular variables we might want to focus at. If we're concerned about how how a certain facet of people are performing on the test, it would allow us to be able to focus in more on that group. So we're going to have three groups, and the first one we're going to get started with is called single value grouping. So to organize data, we first group the observations into classes. So it's very easy to recognize here because this is single values. If you look here at if you look right here at our numbers, these are our classes. Our classes here will range in the 0 to 6 range. So if you look over here, we have our first column. This is our classes. This is our classes. Okay, 0 to 6. Now, what we did in the second column here is we figured out how many are in each class. So how many zeros do we have up here? How many fives? How many twos? And so on. Now this is our single value grouping. So we have a single value to look at in terms of our classes. How many zeros? How many ones? That's our single values. And then we took our frequencies here and divided by the total number, divided each one of them by the total number of classes, or by the total number of households, and we're able to determine our relative frequency. So 1 divided by 50, 16 divided by 50, and so on. Now what this did is it gave us our relative frequency, but remember, relative frequency is just another word for a decimal version of a percent. So actually we could call this 2%. We could actually call this down here 24%, and our total would be 100%. Okay? So our total obviously should always equal up to 100%. Now, there are times when you can have rounding errors in there. So if you have a rounding error, then of course that may make it a little less than 100. All right, so single value grouping. Now, what are our guidelines for grouping? The number of classes. I mean, I know this is, you can read this, should be from 5 to 20. So think about this. You don't want it too large, because what's the purpose of grouping if we've got tons of data? That's the whole purpose, is to break that data down into manageable sets. But you want it you don't want it too large, but you don't want it too small either, because you need to have a representative sample there of the population. So we usually say that 5 to 20 is a good number of classes to have. Um, you don't want classes belonging to, you don't want observations belonging to two classes. It needs to be one and only one. And the classes need to be the same width, so you have a little bit of control and validity in the classes, okay? So, our second part of our grouping is limit grouping. Now, we have some terminology we need to go over first. The lower class limit. Now, that's the smallest value that can go in a class in limit grouping. The upper class limit is the largest value that can go in a class. Now, be careful with what it says here on this next one with class width. The difference between the lower limit of a class and the lower limit of the next class. So for instance, if our, let me turn my pen on here, if our group was, if our class was from 10 to 19, 20 to 29, so on, we would say that this class has a width of 10. Okay, it's the difference in the lower class, the lower limit of this class, and the lower limit of the next higher class. So 20 minus 10 is how we got that number right there. Okay. Now the average mark, the class mark is the average of the two class limits. The average. Alright, so here's a limit grouping example. It says, we've already done single value, so here's a limit grouping. Table 2.6 displays the number of days to maturity for 40 short-term investments. The data are from Barron's magazine. Use limit grouping with grouping by 10, so that tells you your width right there. Grouping by tens to organize these data into frequency and relative frequency distributions. So, what we're going to do is, first of all, let's draw our table. Let's draw our table here. And we have our table. Now, this is going to be our class. So our classes are going to be the days to maturity. That's going to be our classes. Okay. Now we're grouping them by tens, notice. So look over here at your data. Where to start? Well, what's our lowest value in here? Well, just glancing offhand, 36 appears to be the lowest. Correct me if I'm wrong, but I truly believe 36 is the lowest. Okay. And so what we have here is this. We're grouping by 10. So what I'm going to do is with limit grouping, I'm going to say my first class is 30 to 39. That will include all my numbers in the 30s. Because we're grouping by tens, 40 minus 30 giving me 10. This one's going to be 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. Okay, so there are our classes. Now, they want frequency and relative frequency. So let's look at the frequency first. So how many are in each class? So how many are in the 30 to 39 range? Well, if you count that up, there should be 3. How many are in the 40 to 49 range? Well, there should be 1, 8, 10, 7, 7, and 4. Okay? Now that would be our frequency. So what is our relative frequency? Well, in order to find relative frequency, we need to know the total. So add all of these up, and you're going to get 40. So what we need to do is to divide each one of these frequencies by 40. And so you would get 0.075, 0.025, and so on, going all the way down until you got to the end. So that would be how we would get a frequency and relative frequency distribution. Divide 8 by 40, 10 by 40, 7 by 40, 7 by 40, 4 by 40, and that would fill in the rest of your relative frequency. And remember, it should all add up to be 100% or 1. Okay, 1 if you're adding that column up. 100% or 1. Alright, so the last grouping method will be cut point grouping. So the terminology here, the lower class cut point is the smallest value in a class. The upper class cut point is the smallest value that could go in the next higher class, or simply it's the lower cut point of the next class, the next higher class. The midpoint is the middle class found by taking the average of the upper and lower cut points, and the width is the difference between the upper and lower cut points. Excuse me for that. I find more usefulness out of this when we actually put this into a problem. So you've got these weights shown in Table 2.8, given to the nearest tenth of a pound, were obtained from 18 to 24-year-old males. Use cut point grouping to organize this data into frequency and relative frequency distributions. Now notice our class width is 20, and the first cut point is going to be 120. So when you're getting ready to draw your table, we have our classes over here, which our class would be weight. And we're going to start at 120. But remember what our width is. It's the difference in our width is 20, but class width in general is the difference in the lower cut point of the next highest class. So I know my lower cut point of the next highest class is going to be 140. So that means this particular class is going to be from 120 to less than 140. From 140 to less than 160. My next lowest cut point would be 160 to less than 180. And we would keep going here until you see 260, which is less than 280. Now, why do we go all the way down there? Because you're looking at your values here, remember. Here's 278.8, just looking at one offhand. So we know it has to go in this last class. So you want enough classes to cover all your data here. So look at your frequency. So how many are in each class? Well, 120 to 140, there are 3. 140 to less than 160, there are 9. 160 to less than 180, there are 14. And 260 to 280, there are 1. And of course, you've got all these in between here that you could do. 180 to less than 200, 200 from less than 220, 220 to less than 240, 240 to less than 260. Okay, so you've got to fill in all those. Of course, relative frequency. We need to know the total. Well, I'll tell you that since we don't have all these in the middle. The total amount would be 37. So we would divide all these by 37. So 3 divided by 37 is 0.081. 9 divided by 37 is 0.243. 1 divided by 37 is 0.027. So all of this, remember, should add up to be 1. But here's the deal. And this is in your book on page 53 if you want to look at the total chart. But what you're going to do, if you add all these rounded numbers up here in relative frequency, you're going to get 9.999. You're not going to get 1. Why did we not get 1? Well, it's because we rounded. Notice 3 divided by 37 is not going to come out to a nice number. 9 divided by 37 is not going to come out to a nice number. We're rounding throughout this whole process, and so once you round, you may be a little off when you add down through there to get your 1, okay? So be aware of that, but this is how you're getting your dividing these into classes, whether it's cut point, limit, or single value, and getting your frequency and relative frequency table from that. All right, now what is a histogram? A histogram is a graph of the values of observations and how they occur. Now, for single value grouping, of course, we're going to have distinct values. Remember, we had 0 to 6 for the households. You're going to have distinct values to label the bars with. For limit grouping, you're going to have, you're going to use the limit or cut point. You're going to use the lower class limits to label the bars, okay? And I'll show you an example of that here in just a minute. How to construct a histogram. Now follow these steps, step by step, and you will be fine. I'm going to show you 2 perfectly drawn examples from your book so that you don't have to watch my mess. But here is our histogram step. Step 1. Obtain a frequency distribution of the data, or relative frequency, depending on what the problem's asking. Draw a horizontal axis where you're going to put your bars, and a vertical axis where you're going to put your frequencies. So on the horizontal axis, this is where your observations are going. Your horizontal axis, your vertical axis is where your frequencies or relative frequencies will be going. For each class, construct a vertical bar whose height equals the frequency or relative frequency, and label the bars with the classes. Okay? And this just takes practice. This is not anything that's going to be overly difficult for you. Most of you could have probably done this without a video and just read the book. But here's what I mean. We're looking at single value grouping here. Notice how this, we've already done this chart. See how with our histograms here, this is a frequency histogram. We've got our observations or our classes labeled on this side, and we've got the frequency of the classes, how many are in each class, labeled on the y-axis here, and we have our bars drawn. Now notice how these are drawn. So the other one is, instead of frequency, where it's based on relative frequency. But notice, if you look at these two, frequency versus relative frequency, the graphs look very similar. They look very similar, don't they? So keep that in mind. But this is how you would look at single value grouping. A single value histogram would look like this. Okay, so what about a limit grouping? Well, here's a limit grouping. Now notice, these look very similar as well. On the left we have frequency on the y-axis. On the right we have the relative frequency. But on the x-axis is still the classes. Now notice the class is 30 to 39. So this one goes from 30 to 39. That's 3. From 40 to 49, that's going to be 1. From 60 to 69, that's all the way up to 10. Same thing with the relative frequencies. So be careful with your classes. Make sure you're going from 30 to 39, and then immediately stopping at 40 there, and then starting the next class. Immediately stopping at 50, starting the next class, and so on. And cut point is very similar. Notice 120 to 140, 140 to 160, and so on. It looks very similar. So this is basically drawing a histogram is similar to a bar chart, and that's basically what we're doing here. Okay, I have no doubt that you will do well on this. And what you'll notice is be able to draw these out, but more times than not, a lot of these problems are going to be already drawn for you. You just got to fill in some stuff and be able to analyze it. Okay, and we'll know more in the next couple of sections about what we're looking for in terms of analyzing. Right now, we're just talking about drawing. Alright, so a dot plot. This is useful for showing relative positions of the data in the data set. It's really useful for comparing two or more data sets. So how do we construct one? We draw a horizontal axis that shows the possible values, and we record each observation by placing a dot over the appropriate value. Label the horizontal axis with the name of the variable. Okay, so here we are. Here's our data, and with our data here, we have we're just going. Let's say, just so we can do this to the nth degree here. I don't want anybody to leave here confused. These are going to be prices of DVD players. Prices of DVD players. So we would label our horizontal axis with prices. These are prices. It's supposed to be a dollar sign. Bear with me. Alright, so what we're going to do, at 210, we're going to place a dot. 219, place a dot. 214, 197, 224. We've got 219 again. So at 219 we'll go up above it. 199, 199 again, We've got 208, 209, 215, 199 again. We've got 212, 212, 219, and we've got 210. Okay, so hopefully I didn't miss any of those. But dot plots are very similar to histograms. In fact, when data are grouped using single values, a dot plot and frequency histogram are almost identical. So when you are using single value grouping, if you were to look at the dot plot and the histogram, they're almost going to look the same. Okay. However, for single value group data, that will involve decimals. Dot plots are generally preferable to histograms because they're easier to construct. So they're going to be a lot easier for you to make, because obviously you saw how easy that was for me to do here. And it still tells you a relative position in your data, of your data in the data set. Okay, it still gives you the relative position. All right, so hopefully that's pretty easy to you and you don't have very many questions on that. If you do, please contact your instructor. They're going to be very helpful in whatever situation you come across. We're going to work with you in any way we can. So just please contact them if you have any questions. All right, so last but not least, stem and leaf diagrams. And the stem is each observation consisting of all but the rightmost digit. The leaf is the rightmost digit of an observation. These are easier than histograms or frequency distributions to construct. I mean, these are a piece of cake, so to speak. How do we construct them? Well, step one, write the stems from smallest to largest in the vertical column to the left of the vertical rule. Step two, write each leaf to the right of the vertical rule in the row that contains the appropriate stem. Arrange the leaves in each row in ascending order. Okay, so now I'm not going to do every single one of these because I don't want to bore you to death, but here's what we have. Okay, you have stems and leaves. So stem, leaves. Okay, so here's our vertical rule. So all but the rightmost digit will be the stem, and we want to put them in numerical order going straight down the page. Now in a two-digit number, that means this one will always be a stem because we only have two digits, and this one would be the leaf, of course. Okay, so for instance, if we look here, we have numbers in the 30s ranging to numbers in the 90s. So numbers in the 30s all the way down to numbers in the 90s. So that means my stem is going to be the numbers 3 all the way through 9. So my stems are going to look like this. Okay, and as far as my leaves go, what I do, let's look at the numbers that have 30s. Here's 38, 36, 39. These are the three numbers that have 30s. Now the leaves are the rightmost digits of these numbers. So this is going to be a leaf, this is going to be a leaf, this is going to be a leaf. So 6, 8, and 9. Now we want to make sure when you write these down, you don't want to have to do it twice. So let's write them in numerical order. 6, 8, 9. So what that tells you is this is the number 36, 38, 39. So as for 40s, in the 40s we should only have one value over here, 47. So it's just going to be a 7. In the 50s we have several values. We should have 50. We should have two 51s. We should have, and you have to count them twice. Notice we have 153, two 55s, a 56, and a 57. So notice how we wrote that out. Now this is with 2-digit numbers. The left digit would be the stem, the right digit would be the leaf. Okay? Now, what happens if we have, I'm not going to do all the rest of these, I think you probably get the point, but what about if we have 3-digit numbers? Well, 3-digit numbers. Okay? Well, remember the rule. The rule states that all but the rightmost digit, let me go back here. Sorry about that. Says that all but the rightmost digit is our stem. Okay, so stem, leaf. Stems are everything but rightmost digits. So here's the rightmost digit. Okay, so what that means is our stem would be 21, 21, 20, 21, 20. Our leaves would be 0, 7, 8, 5, 2. Okay, all but the rightmost digit. So if you look at this, our stems range from 19. We have 199, that's a stem. We have several stems that have 20s. 208 has a 20 for a stem. 202 has a 20 for a stem. We have 21, 22. Now, go ahead, pick them out. Pick your leaves out. So 9 would be the rightmost digit. That's a leaf. Then we have, for 20, all the numbers that have a 20 at the front, the rightmost digit is going to be 0, 2, 3, 7, 8, 8, and 9. These are all the ones that have 20s as a stem. All the ones that have 21s as a stem are going to be 4. We have 4 210s up there. We have a 212, a 213, a 214, a 215, a 217, and 2 218s. And we have one that has a 22 as a stem. And that is going to be 221, has a 22 as a stem. Now, this is with what we call a one-line leaf. Okay, a one-line leaf. One line per stem. Per stem. I don't know why I said leaf. One line per stem. Okay, so with this particular problem, this doesn't really tell you much, does it? Notice I can't really tell much about the data. We've got too few stems. There's not enough to really give you what the data's doing here. Okay, so sometimes you will need 2 lines per stem. If the data is not giving you what you need with only 1 line per stem, sometimes you have to do 2 lines because it'll be more helpful by having that second line in here. So I'm going to do the stems and the leaves. We do 2 lines per stem. 19, 19, 20, 20, 21, 21, 22, 22. And here's what we could say. The first line could contain leaf digits 0 through 4. The first line would be 0 through 4. Leaf digits 0 through 4. The second line would be leaf digits 5 through 9. So for instance, 19. There's only one with a 19 as a stem, and that's 199. So that's a 9. So we're not going to have anything on this first leaf right here, but we're going to have a 9 right here. Alright, so for 20s, how many stems of 20s have a leaf that is 0 through 4? Well, 0, 2, 3. See, these are the ones that are 0 through 4. So the rest of these would go on the second stem. Okay, same thing here, 0 through 4. So we're going to have 0, 0, 0, 0, excuse my messiness here, 2, 3, 4. And then the rest of this is going to be 5, 7, 8, and 8. And as far as 22, we have a 1, so that's going to go on the first line because it's 0 through 4, remember. And we're not going to have anything on the last line. Now, this spreads the data out more, notice. And it gives you a better idea of what the data is doing. It gives you an idea of being able to determine the distribution of our data when it's grouped tightly together like that. Because notice, all these numbers are grouped tightly together. That's what this first one right here showed. They were all grouped tightly together, and with a one-line stem, it didn't show very much. But if we spread it out over 2 lines, you're able to see the characteristics of the data a little bit better. Okay? Hopefully that made sense. If not, please contact your instructor. Please contact me. You can ask any questions you need. Your instructor will be glad to help you. I hope this has been understandable. Have a great day.